In this problem, we explore a variant of the Monty Hall problem where the three doors are not equally likely to contain the car behind them. So the probability of each door containing a car behind it is given by this vector p. So we have p sub 1, p sub 2, and p sub 3, and these are the probabilities that door 1 contains the car, door 2 contains the car, and door 3 contains the car, respectively. And of course, in the problem, we have one car and two goats. We're told that the contestant originally picks door 3. Monty then opens door 2 and reveals a goat behind it. We're also told that we're also told that Monty always opens the door with the goat behind it. So what this means is, suppose the car is behind door 2 and the contestant has picked door 3. Now Monty needs to pick which door does he open, door 1 or door 2. Well, Monty knows that door 2 contains the car, so Monty will always open door 1. Now we're also told that given a choice of which door to open, Monty will randomly pick one of the doors. So if the car was behind door 3 and the contestant has picked door 3, Monty now has to choose between the two goat doors, and Monty does so randomly. He randomly picks one of the two doors and opens them. Okay, let's make a few definitions. Let's say G sub I is the event that the ith door has a goat behind it. Let's let D sub I be the event that the ith door is opened by Monty. And let S be the event that the strategy of the contestant switching to the remaining door is successful. So the strategy of switching is successful. So what we'd like to know is what's the probability that the strategy of switching to the remaining door is successful, given that Monty has opened door 2 and revealed the goat behind it. So let's reason about this probability here. What are the possible scenarios under which the contestant picks door 3 and Monty opens door 2, revealing a goat behind it? Well, one possible scenario is that door 3 contained the car. Then Monty was free to pick between doors 1 and 2, and he randomly chose between them with probability 1/2. He chose door 2. So the probability of that scenario is p sub 3, that's the probability that door 3 had the car, times the probability 1/2, that's the probability that Monty picked door 2. So another scenario is the probability that both doors 2 and 3 contain goats, and then Monty opens door 2, given that both doors 2 and 3 contain goats. So notice that if doors 2 and 3 contain goats and the contestant had originally selected door 3, Monty will definitely open door 2 because Monty does not want to open the door with the car behind it. So this probability is 1. Now what is the probability that door 2 and 3 both contain goats? Well, it's the same as the probability that door 1 contains the car. So this probability here is P1. And now, out of these two scenarios, out of this scenario and this scenario, for which of these scenarios is the strategy of switching successful? Well, the strategy of switching will only be successful if the car was not originally behind door 3. And that is this scenario here that happens with probability P1. So we have P1 in the numerator. So we get this probability that the strategy of switching is successful under the given observations, under the evidence, is P1 over 1/2 P3 plus P1. So for part B of the problem, we're told, okay, what if Monty does not always open the door with the goat behind it, but rather Monty randomly picks a door? So Monty randomly picks a door to open. How is this scenario different from what we did in part A? Well, in part A, when we were considering the various scenarios, we said that for probability that Monty opens door 2, given that the goat is behind door 2 and there's a goat behind door 3, this probability we said was 1 because Monty always opened the door with the goat behind it. But now this is no longer the case. Monty just randomly picks between the first and the second door, so the probability that Monty will open door 2 is now 1/2. So the only difference is that we have to change the result we got. We have to change the result we got in the first part by updating the numerator to 1/2 P1, and the denominator also we update the P1 to 1/2 P1. And this is a half here, so we can cancel the 1/2s, and we get P1 over P3 plus P1. So again, the only difference was in this term here. And in part B, that term was no longer equal to 1, but was rather equal to 1/2, because again, Monty just randomly picks between door 1 and 2 to open. Now, part C tells us repeat what we got in part A, except with the contestant initially choosing door 1 rather than door 3. Well, we can take the result we got in part A, this result here, and this result from part A, and just replace the values of P1 with P3. So what we get is P3 over half P1 plus P3. And now let's consider D. Well, D says repeat what we got in part B. Remember, in part B, Monty was randomly opening a door with contestant initially choosing door 1 rather than door 3. And again, we can just replace. So the probability that the strategy of switching is successful under this new assumption, so under the assumption that the contestant originally chose door 1 instead of door 3, again, we replace P3 with P1, and we get P3 over P1 plus P3.